In this video, you will learn how to solve polynomial equations by factoring. Many are confused about which methods to use and when. Through some examples, we'll go over all methods of factoring. If you need to refresh on any of these methods, check the links to my factoring videos in the description below. Before we jump straight to an example, I do need to stress some important connections about solving equations in factored form. Now, if you do want to jump straight through an example, you can go ahead and skip ahead. But I do encourage you to stay on this slide with me because these are pretty much the gist on how to solve equations. So the first category is if you have a linear or degree 1 equation, right, where the highest exponent is 1. Now these are the easiest to solve because there's no factoring necessary. So the examples that we're going to be doing is not going to be involving linear equations. It's pretty much going to be a quadratic or a degree 2 equation and an equation where the degree is bigger than 2. Now, super important connection to make. Quadratic equations are in its own separate category. This is because there's an actual formula, and it's called a quadratic formula for a reason, because it's a quadratic equation. So if a quadratic equation is not factorable, we have this beautiful formula that we can use in order to solve these equations. But today is just on solving equations in factored form, and so we're just going to be focusing on solving in factored form. Now, there are 3 factoring methods when you are solving for a quadratic equation. The AC method, so you're going to be looking for that. You're going to look to see if a quadratic equation has difference of perfect squares formula that you can use. And this goes for anything. Always check to make sure that there's a greatest common factor that you can factor out. So there are only 3 types of, these are the 3 types of factoring that we're going to be looking for when we're going to do a quadratic equation. Now, separately, if you have an equation where the degree is bigger than 2, there's no beautiful formula that we can use to solve an equation. Now, what happens if an equation where the degree is bigger than 2 is not factorable? Then we are going to be using the rational roots theorem, and that involves long or synthetic division. So I am going to be creating a separate video for that. Now, we are just going to be focusing on solving using factored form. So if you have a degree bigger than 2 equation, the 3 methods, you're always going to be looking out for the greatest common factor. You're going to be looking out for factoring by grouping, in which you need 4 terms, and be on the lookout for sum and difference of cubes. Let's jump right to an example. So here we have a degree 2 or a quadratic equation. How do I know that? Because the degree, as I said before, is 2. The highest exponent is 2, right? So first step is I'm going to be going up on this slide a lot. I've broken it down into 3 simple steps. So always make sure when you solve an equation in factored form, step 1 is to make sure that the equation is set equal to 0. Now, if it's not, you're going to add and subtract terms to the other side of the equation. So notice this example right here. First step it has to be equal to 0. It's not. So how do we get that negative x together with the x squared? Is we can add x to both sides. The x's cancel. On the left side of the equation, we get x squared plus x. And on the right side of the equation, we get 0. So now this is where we're starting, right? So we're always got to make sure a quadratic or any equation is equal to 0 before factoring. Okay, so step 2 is we're going to use our various factoring methods depending on what the problem is, and we're going to actually go ahead and factor. Now, before I did stress, we're talking about quadratic, right? So we're focusing in this area here. The 3 type of methods that you should be looking out for when factoring is the AC method, see if it's a difference of perfect square scenario, or greatest common factor. Those are your 3. Okay, so it's clearly not a difference of perfect squares. We're not going to use the AC method because it's actually simpler by taking out the greatest common factor. So the greatest common factor is x, because both of the 2 terms here have an x in common. So when we factor out a greatest common factor, it's just like the reverse distributive property. X times x gives me x squared, and x times a positive 1 gives me x. Now we have successfully converted the standard form equation into factored form. So then step 3 is you're going to set each expression inside all of the parentheses equal to 0 and then solve for x. So if you notice down here, we technically just have this parentheses here, right? So we're going to set, so if I were to kind of split it up into partitions here, right? So we're going to set this guy here equal to 0 and solve for x. So we can subtract 1 on both sides and we end up with x equals -1. Now we are missing an answer. So I did say up here in step 3, note, if there are any variables outside of the parentheses, then this means that one of the solutions, aka roots, is 0. So notice we have an x here that is a variable outside of the parentheses. So automatically, that means one of the roots is 0. So we have two solutions, x equals 0 and x equals -1. Let's look at another example. We notice that this is not a quadratic equation because the degree is 4 here. And step 1 is already completed. We had to make sure that the equation is set equal to 0. So the next step is to factor this. Now, a reminder, since this is not a quadratic equation, we are looking at this category. When we are looking to factor a degree bigger than 2 equation, these are the 3 scenarios. We're going to look for the greatest common factor. If it's 4 terms, we can factor by grouping, and you're going to always look out for sum and difference of cubes. So let's take a look. Okay, this is not 4 terms. Here are 3 terms, so we cannot use factoring by grouping. This is clearly not sum or difference of cubes scenario, so we can't use that formula. So our last trick up our sleeve is figuring out, does this have a greatest common factor? And we see, yes, it does. It's x squared because each of these 3 terms have at least 2 x's in common. So we're going to go ahead and factor out the greatest common factor from each of these terms. And again, it's like the reverse distributive property. X squared times x squared gives me x to the 4th. X squared times a positive 8x gives me the positive 8x to the 3rd. And x squared times a -9 gives me that minus 9x squared term. Now, you want to factor it completely. So we have to see, is this guy here completely factored? So this is a quadratic expression here. So we're going to go up here into the quadratic category, right? So the 3 methods of factoring a quadratic equation or expression is we're going to look for the AC method. Is this a difference of perfect squares? We can use that formula. And greatest common factor. Does this share a greatest common factor? Okay, so there is no greatest common factor here. This is clearly not the difference of squares formula. So let's check out if we can use the AC method. Right, so here, the leading coefficient A is 1, B is positive 8, and our C, which is the constant, is a -9. Now, since the leading coefficient is 1, this is going to be the shortcut method. In other words, we don't have to use factoring by grouping here. If you wanted an example where you had to factor a quadratic equation where A is not 1, take a look at that factoring method in the description below. I've created a separate video. But in this particular case, the leading coefficient is 1. So the AC method is we're going to multiply A and C together. Oh, I wanted to use a different color there. How about green? Right, so 1 times -9 is -9. We're going to create a factor tree of the A times C. So we can do -9 times +1, or +9 times -1, or +3 times -3. And I don't have to bother writing -3 times +3. So next we have to see which one of these pairs add up to +8, because that's B. And it looks like the +9 and the -1 work because 9 plus -1 gives me +8. So last but not least, since this is the A equals 1 method, we just write those chosen factors into our template. So this is our template. Now, +9 is one chosen factor, so I'm going to write +9. and -1 is the other chosen factor, so I'm going to write a -1. Now don't forget to bring this x squared down here. Okay, so we have just factored this quartic or degree 4 polynomial completely. So we have to set each expression inside the parentheses equal to 0. And don't forget, like the previous example is, we do have a variable outside of the parentheses. So automatically we know that one of the solutions is x equals 0. Now, just as a side note, why is that true? Is because the x squared, right, this over here, I can actually write it down as x plus 0 times x plus 0, right? Because x plus 0 is x, and x times x is x squared. So x squared, I could rewrite it as a product of these two expressions, and we can clearly see that if I were to set both of these equal to 0 and solve for x, I clearly get 0 as one of the solutions. So that is actually the reasoning for why, if there's a variable outside of the parentheses, it's automatically one of the roots is 0. Okay, so now we're going to also set x plus 9 equal to 0, and we're going to set x minus 1 equal to 0. So when we solve for these equations over here, if we subtract 9 on both sides, we get -9. And if we add 1 to both sides, it's a +1. So a lot of people like to think of it as they're just going to be opposite signs. Here's another example, and then I have one more for you guys later. So again, step 1 is to make sure that the equation is set equal to 0. In this case, it's set equal to 12. So we're going to subtract 12 from both sides of the equation because it's a +12. So we end up with x to the third plus 3x squared minus 4x minus 12 equals 0. So that's step 1. We've set it equal to 0. Next step is to fully factor this equation. So again, this is not a quadratic. This is a degree 3 polynomial since the highest exponent is 3. So we're going to take a look at this category, right? And again, the 3 tools are the greatest common factor. If it's 4 terms, we're going to try out factor by grouping, and we can take a look to see if there's a sum or difference of cubes formula that we can apply. Okay, so if you notice, there are 4 terms. So let's take a look if we can use factoring by grouping. So we're going to create our 2 groups. And again, if you forget how to factor by grouping, take a look at my factoring by grouping video in the description below. Okay, so in the first group, we can pull out an x squared. X squared times x gives me x to the third. X squared times a +3 gives me 3x squared. Now we can take out a -4 from both sides. Excuse me, from both terms in this group. -4 times x gives me -4x, and -4 times a +3 gives me a -12. So how did I know to take out a -4 and not a +4? Well, you can try it. If you were to take out a +4, you would end up with -x minus 3. Now that wouldn't have worked because we want matching expressions. So we know that this is correct because we wanted x plus 3's to match. So believe it or not, we have 2 terms here. So if we pull out the greatest common factor from these 2 terms, they both have x plus 3. So the greatest common factor is x plus 3. So when you pull out an x plus 3 from each term, you end up with x squared minus 4. Okay, so have we fully factored this equation completely? We have not, right? Because we can factor this guy. How do I know that, by the way? Something is factorable, or I should say, an expression is not factorable if it's degree 1. So notice the x plus 3, I can't factor it anymore because this is linear, or the degree is 1. But if the degree is not 1, it could be factorable, maybe it's not. But in this particular case, this is quadratic. So just really quickly, right, in a quadratic scenario, The three factoring methods are, you could take a look if it's the AC method, you could see if it's difference of perfect squares, and you could check out if you can take out a greatest common factor. And in this particular case, this is a difference of perfect squares. So difference of perfect squares, if you're a little iffy on this method, you could take a look at my difference of perfect squares factoring video in the description below. Otherwise, we can break this up into x plus 2 times x minus 2, or you could have written x minus 2 times x plus 2, does not matter. Don't forget to copy down this x plus 3. All right, so we have fully factored this polynomial equation. Last but not least, we're going to then set each expression inside of the parentheses equal to 0, and we're going to solve for x. Okay, and a lot of people like to think it's just going to be opposite signs as the solutions, and they are right. Right, so here you should get x equals -3. Here is x equals -2, and x equals +2. Now there is no variable on the outside, so x equals 0 will not be a solution. So these are our three solutions. Last but not least, let's try out this example. So very first step is check to see if the equation is equal to 0, and it's not. So we have to subtract 27 from both sides. Now, actually, before I do that, I've seen many students, like if the direction were to solve this cubic equation, a lot of people will say, okay, well, the opposite of cubing is taking the cube root, right? And they'll say, oh, x is equal to 3, right? Because 3 times 3 times 3 is 27. Now, that is only one of the roots, right? Because the degree here is 3, that means there's going to be 3 roots. Whether they'll be real or imaginary, that's a different story. So we are going to be looking for 2 other missing roots because there should be 3 roots in total. So let's subtract 27 from both sides, and we end up with x to the third minus 27 equals 0. So now let's see if it's factorable. So this is not going to be a quadratic equation. We are in this category because the degree is 3. So we're going to check out, can we use the greatest common factor, factoring by grouping, or is this sum and difference of cubes formula? So there's no greatest common factor. There's only 2 terms, so we can't factor by grouping. And if you've noticed, this actually, we can use the difference of cubes formula. And again, if you forgot this method, take a look at the description below on how to use this factoring method. But pretty much this formula, if you have a difference of perfect cubes, the formula is the minus plus plus, right? So we're going to subtract the cube roots a and b, then we're going to square a, add a times b together, and then add b squared. So here is the difference of cubes formula. Now a reminder, what's a and b? A is going to be the cube root of the first term. So the cube root of x to the third is x, and we can check because cube literally means that if we multiply something by itself 3 times, so in this case, right, x multiplied times self 3 times does give us back x to the third. So we have successfully taken the cube root there. So a is the cube root of the first term, b is the cube root of the second term, okay? And then they're being subtracted, right? So a lot of people might get confused that it's a negative 27, but we're just looking at in that spot. So the cube root of 27 is 3, because 3 times 3, right? 3 times itself 3 times does give us 27. So that's the cube root of 27. So now once you figure out what your a and b is, we can just substitute it into this formula. So we're going to do a minus b, so that's x minus 3, And then we're going to do a square a. So a is x, so that will be x squared, plus a times b, so that's x times 3, which is 3x, plus b squared. And b is 3, so we're going to square 3. 3 times 3 is 9. Okay, so we're going to see, actually, I will do a shortcut. I did explain in my difference and sum of cubes formula that whenever you use this formula, the quadratic piece will never, ever, ever be factorable. Now, if you don't believe me, this is a quadratic, so we can try and use the AC method. A is 1, B is 3, and C is 9. So if we multiply A times C, so that's 9. If we look at all of the factors of 9, so negative 9 times negative 1 works as well, right? And then we could do 3 times 3, and also a negative times a negative is positive. So these are all of the factors. Now, if you add all of these up, there are no pairs of factors here that add up to 3. If you don't believe me, 9 plus 1 is 10. These guys, when you add them up, is negative 10. 3 plus 3 is 6. Negative 3 plus a negative 3 is negative 6. So notice there's no factors of A times C that add up to B. Or whenever you do the sum and difference of cubes formula, as I said before, the quadratic piece will not be factorable. So here's the x equals 3. We already knew that was a solution. But the problem is, as I said before, this is not factorable. So how do we get these two solutions? Since it's not factorable, remember I said from the very beginning of this video, because it's a quadratic equation, there is a nice, beautiful formula that we can use. So we'd have to use the quadratic formula. So this problem would be just solve for the roots. You can't solve fully by factoring, as I said, because in this particular case, we need to find these other two roots using the quadratic formula. Now, when you do this, I'm not going to spend time on this, you're going to end up with two imaginary roots. They're going to be imaginary because there's going to be a negative number under the square root. So in this particular case, we're going to end up with one real root and two imaginary roots. Okay, so I just wanted to take some time and go over a difference of cubes formula. I wanted to kind of add that in. I hope this video helped you learn how to solve polynomial equations by factoring. Check out links to other videos in this unit in the description below. If you like this video, make sure to subscribe to my channel right now. That way you don't miss out on my future videos like this one. Just click on the subscribe button.